Okay, so in this problem, we need to find the equation of the line passing through the points. So we're going to need the slope, the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You can label your points x sub 1, y sub 1, and x sub 2, y sub 2. That's a good way to do it. It'll help keep things straight. So you get the slope is equal to negative 34 minus 6 over 3 minus 0. Okay. So it looks like I'm getting negative 40 over 3 for the slope. Kind of a weird slope, but that's what it is. Make sure I have everything right there. Yeah. And then it turns out that this point right here, that is actually the y-intercept. So I know B is 6 because that's the y-intercept, okay? If you didn't do that, you could have used the point slope formula. The point slope formula looks like this. So you might have done this. This is a little bit longer, but it's going to work out just lovely. So y minus 6 equals that slope we just figured times x minus 0, because you already have the x sub 1 and y sub 1. Okay, so that gives you y minus 6 equals negative 40 over 3x. And then you just have to add the 6 over, so you get the equation y equals negative 40 thirds x plus 6. Most people that got it right had it in that form. So. Okay. State the domain and range of the function in interval notation. Again, with the interval notation. Again, we're walking for the domain. We're walking along the x-axis. Okay. So when does the graph start? Well, it starts here at negative 4. There's nothing before that. Okay. So here I am walking along. There's no graph until I get to negative 4. That's where it starts. And I'm going to include the negative 4 because that is a solid dot. When I'm walking, I'm walking, I'm walking. There's graph everywhere. See, I can jump up and hit the graph, or I could jump down and hit the graph. But there's graph here. There's ordered pairs until I get to 4. And then it's when I continue, there's no more graph. So it's going from negative 4 to 4. That is the interval, okay? So you're Mario and you're walking along in any place that you can jump up and hit the graph or jump down and hit the graph. That is in the domain, okay? So it's this section in here from negative 4 to 4. All of those domain elements have a matching range to them. It has an ordered pair, okay? Right now I'm going to erase this. That's why I'm doing the video. And now you're Spider-Man. You're walking up the, you're Spider-Man. You're walking up the y-axis. When do you start getting, and now you're jumping sideways. You're jumping this way or this way, and can you hit the graph? Well, down here you can jump, but there's no graph. Not jump, I guess, slide. I don't know. Anyway, it doesn't start until 0, okay? So I have a big mess there and you can't see my 0. But right here, that's where I finally get a point on the graph. So I'm looking for the range. And I have points, I have points, I have points until I get to 2. So the range is going to be, it's an interval notation. We are going to include the 0. There is a point there. That's a closed dot. So we are including 0. In fact, there's 2 points, but we don't care. It just has to be at least 1. And then it's going and going and going until I get to 2, and then there's no more graph. Okay, so I'm hoping that helps. That's the range. Hopefully it all makes sense. Sometimes after you do the problems and then you look at your answer, you're like, oh, okay, I see. So hopefully that's happening. And then there was some problems with the average rate of change. So some of you may not have realized you needed like the formula for the average rate of change. And the formula for the average rate of change goes like this. It says you take f, your function, evaluated at x sub 2 minus f evaluated at x sub 1 over x sub 2 minus x sub 1. So when we're doing average rate of change, they have to tell us what we're going from, the specified interval. We're going from x being negative 2 to x being 2. That's the interval that we're using. They tell us x sub 1 and they tell us x sub 2. Okay? Those you can just plug in right there at the bottom, right? Okay, so you're going to put in a negative, I'm sorry, you're going to put a 2 here and a negative 2 here. That's x1 and x2. But what happens in the numerator? Well, you have to find f of x sub 2. Now, it's going to equal 3x sub 2 cubed minus 1. But you know what x sub 2 is, right? There, it's 2. So what we really want to know is what's f of 2. And then some people had that, but they didn't do the order of operations correct. Again, you need to do the exponent first. So 2 cubed is 8, 2 times 2 times 2. And then you're going to have 24 minus 1, which is 23. That is this part right here, x sub 2. That's going to be the 23. Okay? I'll write f of x sub 2. How's that? Is 23. Now you have to find the other one where it's negative 2. So you have to find f of negative 2. That's going to be f of x sub 1, because x sub 1 was negative 2 right there. Okay. So that's going to be 3. You're using the same function, but you're putting in a negative 2. So you're going to cube that negative 2, and that's going to give you negative 8. And then you're going to have negative 24 minus 1, which is negative 25. Okay, so we have all the pieces to the puzzle. We just have to put everything where it goes. So remember, it's f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Okay, so what is this part? Right there. That was 23. Okay, so 23 minus negative 25. That was the x sub 1 right there. And then over, we had the 2 minus a negative 2. And so you wind up getting 48 over 4. And then that wound up being 12. So some people got it right, but I know some people struggled with that one. So hopefully that helps.